Okay, so now that we have reviewed all of our exponent laws, we're going to be looking at solving exponential equations using those exponent laws. We always want to keep those in mind. So first we're going to do a quick review of solving equations because we're going to need this as we solve our exponential equations. So remember, when you're solving an equation, then to isolate the variable, to get that letter by itself, you want to go opposite of BEDMAS, so you want to use SAMDEB. So that means you're going to be moving any subtracting and adding first, then multiplying and dividing, and then exponents, and then brackets. So the first one here, we have x minus 8 equals 7. We want to move that minus 8 to the other side. That'll become a plus. So x equals 7 plus 8. And we get x equals 15. The next one, we have 4x plus 1 equals 9. Again, using our SAMDEB, we want to move adding and subtracting first. So we have a plus 1 here. We want to bring it to the other side. It'll become a minus 1. So 4x equals 9 minus 1. So 4x equals 8. The operation between your 4 and your x is multiply. Bringing it to the other side is divide. So x equals 8 divided by 4, which is 2. Our next one, we notice that we have constants and variables on both sides. So what we want to do is move our variables to one side and our constants to the other. So what we can do is move this minus 2x to this side and move this plus 5 to this side. When the minus 2x comes across, it'll be plus. When the 5 goes to this side, it'll become minus. So 11 minus 5 equals x plus 2x. So then we combine our like terms. 11 minus 5 is 6, and x plus 2x is 3x. Getting x by itself, we want to move that multiplying by 3 to the other side, and it will be divide. 6 divided by 3 equals x, 2 equals x. Okay, the last one here. We're first going to multiply the 2 out front by both things in the brackets, since we have two different terms here. So we have 2x minus 12 equals 4x. We want to have the x's on the same side, so we can move this 2x to the other side. It'll become a subtract 2x. So negative 12 equals 4x minus 2x. Negative 12 equals 2x. Getting x by itself, we are then taking this multiply by 2, bring it over and divide. Negative 12 over 2 equals x, which is negative 6. Okay, so now going into solving exponential equations. Equality of powers with a common base. So our goal is to create the same base. If we have the same base, then we can drop the base and just solve the exponent piece. So the first question is 4 to the exponent x equals 4 to the exponent 3. Since these both have a base of 4, we can drop the bases and just write the exponents, and that is x equals 3. Okay, that is our answer. There's nothing for us to solve there because x is by itself. Looking at the next one, we have 3 to the 2x equals 3 to the 36. We have the same base. They both have a base of 3. we can drop the base and just write the exponents. So 2x equals 36. To solve for x, we need to bring that multiply by 2 to the other side, and we'll divide. So x equals 36 divided by 2. And we get x equals 18. And the third question here, 2 to the 6 equals 2 to the 3x. Again, same base, they are matching 2 and 2. We can drop the base and just put 6 equals 3x, just keep the exponents. To solve for x, we want to move the 3 to the other side and it will become divide. So 6 divided by 3 is x, so 2 equals x. Okay, so you can be given questions where the base is not the same, and your goal is going to be to make the base the same. So looking at the first one, we have 3 to the exponent x equals 27. So we want to make this 27 as an exponent with a base of 3. So 3x equals 3 to the exponent something, which will give us 27. So 3 to the exponent 3 gives us 27. Okay, this might take a little trial and error with your calculator to find out what works to get the same base here. Once the bases are the same, again, you can drop the base, just keep the exponent. So we have x equals 3. Next one, we have 4 to the exponent 2x minus 4 equals 16. Here we do not have the same base. We want to create the same base by making the 16 a power with a base of 4. So 4 to the exponent 2x minus 4 equals 4 to the exponent 2. Again, once we have the same base, we drop the base, keep the exponents. So 2x minus 4 equals 2. And we want to solve for x. So first we're going to move that minus 4 to the other side. It'll become a plus. 2x equals 2 plus 4. 2x equals 6. And then we move the 2 multiplying on this side. So bringing it across the equals, we'll be dividing. X equals 6 divided by 2, and our x equals 3. And the last one here, 2 to the exponent x equals 524,288. Okay, so this could take a lot more trial and error. You want to get a base of 2, meaning you're trying different exponents with the base of 2 until you can get to this number here. Okay, once you find it, so our answer here to get the 524,288 is 2 to the exponent 19. So once you have the common base, we have just our exponents left, so x equals 19. Okay, so we have 2 to the exponent x plus 1 equals 8. Again, we need to find a common base, which will be 2, so we need to change our 8. So 2x plus 1 equals 2, and that'll be to the exponent 3. So dropping the bases, we have x plus 1 equals 3. Solving for x, we bring that plus 1 to the other side. It'll be a minus. X equals 3 minus 1. And x equals 2. And we have 625 equals 5 to the exponent to x plus 1. We need to make this 625 a power with a base of 5. And that's going to be 5 to the exponent 4. And we set that equal to the other power, 5 to the exponent to x plus 1. With the same base, we just have our exponents left over. 4 equals 2x plus 1. Move the plus 1 over, becomes a minus. 4 minus 1 equals 2x. 3 equals 2x. Bring the 2 over and divide. 3 over 2 equals x. Okay, and we can keep that as a fraction or make it a decimal. So 3 divided by 2, that would give us 1.5. On this slide here, we're going to be tying in other exponent laws. So keeping all these in mind, looking at the first one, we have 3 to the exponent 5 minus x equals 1 over 3. Remembering that when you have a negative exponent, it's 1 over that positive exponent. So we can actually rewrite this as 3, 5 minus x equals 3 to the exponent negative 1. Okay, since the 1 over 3, the 3 has that invisible 1 as the exponent here. Okay, we now have the same base, so we are just going to be left with 5 minus x equals negative 1. We're going to bring the 5 to the other side. It'll be a minus 5. So negative x equals negative 1 minus 5. Negative x equals negative 6. And getting x by itself, we need to divide by negative 1. So x equals negative 6 divided by negative 1. And x equals a positive 6. Okay, and the next example, 8 to the exponent 5x minus 10 equals 1. Okay, thinking back to our exponent laws, anything to the exponent 0 gives us 1. So that means we can make a power with a base of 8, and the exponent will be 0. So 8 to the 5x minus 10 equals 8 to the 0. We have the same base, now just keeping our exponents, so 5x minus 10 equals 0. Solving for x, we're going to bring that minus 10 to the other side. It'll be a plus 10, so 5x equals 10. And getting x by itself, we need to move the multiply by 5 to the other side. It'll be divide. 10 divided by 5, and x equals 2. Okay, and our last examples here. So with this one, we have 9 to the x minus 1 equals 27. If we think about this, we cannot make 27 as a base of 9 to match these up. But what we can do is make both of them a base 3. So if we change the 9 into a base 3, that's 3 squared. to the x minus 1. And then our 27 is 3 to the exponent 3. Okay, remembering our exponent laws, when we have a power of a power, that means we multiply. So we are going to do the 2 times x and 2 times negative 1. So we're going to get 3 to the exponent 2x minus 2 equals 3 to the 3. Okay, same base, we can drop those and we're just left with 2x minus 2 equals 3. Oops. We'll bring our minus 2 over, it'll be a plus. So 2x equals 3 plus 2, 2x equals 5. And bring the multiply by 2 over and divide. X equals 5 over 2. And if we want to make that a decimal, we get x equals 2.5. Okay, you can always go back and double check your work. So we could put 9 to the exponent 2.5 minus 1. So 9 to the exponent 1.5. And make sure that our answer is 27. Okay, in our next one, we have 16 to the exponent 2x plus 1 equals 64. Okay, so we cannot make the 64 a base of 16, so we need to think of what we can make the base to be the same, and what we're going to use is a base 4. So 4 squared to the 2x plus 1 equals, okay, might take some trial and error to figure out. The 64 will be 4 to the exponent 3. Okay, again here we have power of power. So that 2 is going to be multiplied by our 2x and our 1. So we're going to have 4 to the 4x plus 2 equals 4 to the 3. Having the same base of 4, we'll drop that. Just solve the exponents. 4x plus 2 equals 3. And we solve for x. So bring the plus 2 to the other side. It'll be a minus. We have 4x equals 1. Bring the 4 over and divide. X equals 1 over 4. Or if we want to make it a decimal, x equals 0.25. Okay, again, if you want to check your solutions, you can always put x back into the original equation and solve, and make sure your left side is equal to your right side. So here are your textbook questions for today. If you have any questions, please let me know.